So now let's have a look onto the functions specific to I/O and string functions and file I/O functions in determining the end of file in Unicode specific files. So we do have these functions. I'll just demonstrate them to you here. And for example, let's look into the printf first. Whenever we have printf, we use it for ASCII, but the equivalent that we use for Unicode string is wprintf, which means wide printf. We should call it like that. Then the scanf, these are the two functions that we use most frequently. This printf, we use it very frequently. In the scanf, that we use very frequently. These are the I/O functions which have equivalent wscanf here and wprintf. Exactly the same way the sprintf that we use for printing onto the source of a variable or something into the variable, string variable. And if you do it with the wide string, wide characters, then you'll have to use swprintf. Now the string functions, we used these functions previously when we were studying the string functions. String cat for the concatenation, and then we had string copy, strcpy, and strcmp, and strcmpi. Now, pretty much three of the functions on top are exactly the same, except for instead of the str here, this str here, this is the str part, it is replaced with the wcs. If you notice it, this is replaced with wcs. And then instead of str, we have wcs, and rest of the string is exactly the same. In string compare case, we have WCS ICMP, not CMPI. This is the difference. You just need to remember. This is exactly the same. If you see, we have STI here, and we have WCS here. And then you remember when we were doing file I/O, and we used some functions like fprintf. This has an equivalent for the wide string is actually fw. F is exactly the same. And then in between the printf and f, there is a w. And exactly for scanf, then you will have fw scanf. Instead of f scanf, fw scanf. And fgetS, to get a string, then these are the functions that we are going to extensively use in our student project, database project that we are going to do. And you have equivalent of fgetS is fgetWS. So this is not following the rule exactly, but you'll have to remember this if we need them in the future. So let's get to next functions. Then we have putS, which have equivalent function fputWS, fputS and fputWS. Then if you remember, we had getC and fgetC. So this is the function fgetC to get one single character, ASCII character from a file. And then we have the equivalent for the wide character. We'll read 2 bytes. And then putting back a character into a file, single character, and this is the Unicode character that you want to put back to the file. Now, the most important thing in here is when you use fwprintf, let me give you an example. Okay, so let's get back here. So we have wprintf. We're going to just add a w here, and rule is whenever you're using Unicode functions, you need to modify the strings to be Unicode as well. For that, you will have to add a symbol L in the start. You just bring it here. So the problem of editor, and here you go. Here. So any string that is considered, you want it to be considered as a wide string by the compiler, it should start with L and then in the double quotes anything that you use. Now there's one more thing, important stuff, is that there are format specifiers which are a bit different. So pretty much every format specifier that you are going to use in wprintf and wscanf and fwscanf and fwprintf, you are going to have to start them with L. I'm just going to create one example here. Just erase this. I'll say L, and within this, I'll have to specify. For example, I'm trying to print a string, then I'll be using %ls, not just s. Previously, let me just duplicate this. What we were doing previously was printf, and there was no specifier here before the start of the string, and we were using it like this. Now we have modified it, included w in the beginning, L in the start of every string, and then we have %ls. So exactly the same thing that you are going to use for example, float. So it will be LF. If it is complex you want to print, or a double, long double, we use E and G for them. And %D, %I, %H that we have studied previously are going to be exactly the same. If we need to print a character that we used to print with %C, now we'll be using %LC. I hope it makes sense. If you have any further question about it, just let me know. I'll be answering that. Now, when we were using file system, if you remember, we used a constant, a predefined constant. Let me just write this pseudocode here, this possible code here. Will not be making any sense because we did not define the file. If you remember, we were reading C is equal to F get C. And we were getting 1 byte, reading 1 byte from the file. And we were checking immediately if C equals to EF. That was end of file. Then we were breaking the loop and exiting out of it. This is a finite loop. If you remember in the previous examples, the file IO chapter. Now, when we are willing to read a wide character from the file, of course, we'll have to use W character _T. Some of the systems are going to allow you the W character only, and some will not. So you will have to use W character _T, which is the standard, instead of W character. So W character T is what you need to use. And for F, if you remember, the F get C, we had a function called F get C, which has equivalent of F get WC. So we'll use F get WC here. Once read, we will be checking it, comparing it with WEOF, wide end of file. So we will be checking this way instead of only EOF, which would not make any sense to the program. So this is how you determine the end of file when using Unicode data. If you have any further question, let me know. Thank you.